Hello everyone, welcome to the first lecture of your Niagara VFX. So while we started, we have to understand the basic concept of Niagara, and before we create any VFX, what things we'll be needing before we start creating it. So the first thing, what is a Niagara? So in your Unreal Engine, it's basically a more optimized version for you to create any VFX or using the particles. It won't be bottlenecking your CPU in comparatively other ways while you'll be creating using some other method. So the two type of method that we'll be discussing here will be your blueprint, and the second one will be your Niagara emitter. Before we move on to the blueprint and Niagara emitter parts, we have to understand the core concept or the core components to create any VFX. Okay, so to create any VFX, any kind of VFX, let's say the fire one, you can see it here. Even for that, you need two things. First is your Niagara emitters, and second your materials. Whereas both are equally important, Niagara emitter works on the logic, the behavior of the particles, while the materials is basically, as per the name, works for the visual and how it seems to the user. So these two have their own roles, but they both, depending on each other, are more important or equally important. So while we start creating an a Niagara, it can be done both ways using a blueprint, which is seen in the graph paradigm, whereas you can also use Niagara emitter, which you can find in the panel where it's shown, that is called the stack paradigm. While blueprint is much more, you can say that we can control a lot more nodes. We can create a highly more complex kind of VFX, but the main issue it have is you have to have a really good understanding of nodes and how they'll be connecting using the points. Okay, so for the blueprint, the older user, I guess, understand it much more better, but if you're starting your Unreal Engine journey just now, you don't have to focus on the blueprint one. The Niagara emitter is much more easier part, whereas it have much more, you can say, friendly user interface, and here you have to have more understanding of those confused node networks. By node network, I mean the threads or the points that will be connecting from each nodes to some other nodes, and basically they works together to create some kind of effect or some works in your Unreal Engine. Well, this seems just like this. Okay, so it's in the form of a stack. You have to remember that the Niagara emitter, okay, while it's in the stack form, the thing that is more on the downside works on top of the other one. Okay, so if you think it as a layer system, instead of the layer that is on top, we look the more, it start working from here. Okay, from top, start working on the bottom. So if there is something coming before it, okay, let's say this one is running, okay, and here a different command is also there, and this one is canceling it. So first your system understands this setting, but as it moves to the next one, the other one cancel out the first guidance or the first command. Okay, so you have to remember it works in a stack manner. The next thing comes to the advantage and disadvantage. So both have their use cases. Okay, both are better in their own way. As I've already told, that it have more flexibility and it's more logical based, means you can create using this a lot more complex VFX, while if you use it, you can create more, or you can say GPU friendly. Okay, it is more optimized form because it's directly implementing onto your it basically uses the CPU and it uses the GPU ones. Okay, so you can just read out the advantage and disadvantages. It'll be also starting with the Niagara, you can say the graph, not the graph one, the stack paradigm, whereas you'll be using Niagara Emitter. So you'll be starting to create those logics before you move on to the blueprint one. You have to understand what works they do and how it's done, while you just use the keys to move them up and down. Okay, so while you're here, starting from your Niagara VFX simulations, so you have to understand there are a few things that is called modules. So the modules are the ones which you are seeing here written in the white. So as we write codes, okay, as your nodes work in your blueprint part, in the Niagara emitter, your module works as kind of codes. So they are the kind of codes which is already pre-written. Okay, they have a particular type of behavior that will be affected onto your particles to create an effect. So for it to be worked, you have to understand how they works. Even though you have a lot of modules, okay, if you press plus on these ones, you get a lot different types of module. You also have to have the understanding which module should be used in which of these options. Okay, it might be confusing for right now, but still better to get a concept for your understanding. In the starting, it can be a bit hard for you to understand this, but with time, we'll be doing exercises and we'll be creating few smaller VFXs or few smaller, you can say, practice to start getting used to it, start remembering those particular modules. As I've said, the things that are called module, they're basically building block. Okay, they are in the stack form. Okay, the white written, these things, they already have a pre-written logic in them. So let's say you have this spawn, okay, something. So here the spawn burst works for the particular part or the emitter state. Okay, so when your emitter starting or when your particle is starting the work, it starts with the spawning part, then it gets to the update part, then it gets to the particle spawn and particle update. We also be explaining or talking about these things in the future tutorials. So for just now, understand that they already have some pre-roles written inside them, and you are just picking them from a lot of group and just putting them here and clicking on the tick one for it to start working on your particle. Okay, stack integration done. Okay, so there are a lot of modules, as I've said. Okay, so it will take your time and understanding and your experimentations for you to start getting used to it. Here we already have discussed about the Niagara. Okay, so to create a Niagara VFX, we already know the Niagara emitters. But for Niagara to work, the important role that the other part is of materials. Okay, so as already discussed, the Niagara is your behavior, okay, how your particle will work, whereas your material how it will look. The how it will work part, the Niagara part also controls its size, its life, its movement, okay, all those kind of things, while the materials handles your texture and layering part. So how it seems, how it feels, and how you want your particles or the VFX to come out in the end. Okay, so these are few things that we'll be understanding later in the future. As you have seen here, the ones which have plus options. Okay, so they have their own individual roles that we'll be discussing in the future tutorials. And the modules also is blueprint. As I've said, blueprint is basically having those nodes network, and your modules have their predetermined codes. Okay, we can also write those codes. We can also create particular modules that also will be doing in the future classes, but just a basic understanding, basic thing that's getting again repeated, what those things are and how they are done. Okay, so in the today's lecture we have discovered what is Niagara, okay, and how you have to create VFX. For creating a VFX, the things you have needed are Niagara and materials. Okay, after that, for Niagara part, how you'll be creating it, you have both options as blueprint, that is your graph paradigm, and your Niagara, your emitter part, that is inside your stack paradigm. While you'll be creating it, the other things that we have learned today is what are modules, okay, and how you'll be using modules into your Niagara emitter, and what is the role of your material. So that's all for today's class. We'll be continuing with the next topics and most probably the practical demo for your better understanding. Thank you. Let's meet in the next lecture.